Okay, this video is going to be about the first 4 rules of differentiation. Now you'll notice a section in your course content called 4 rules, which will list the 4 rules that you see over here in the easy way. And you will remember the hard way from the previous video and hopefully from the course content and homework you've been going through. Now at this point I hope you've worked a couple dozen problems at least the hard way. It's important to know it, it's important to see the definition. And I hope that in walking through things the hard way, you've noticed that there have been patterns to your answers. In fact, many people figure out the easy way on their own just by working the hard way over and over again and observing what happens. So what I want to do is show you how to take derivatives of things more quickly than you have been doing the hard way. So we're going to work a quick example from each of the easy way to show you how it goes in action, get you started. Then I hope that you take this to the homework and practice them yourself. Seriously, the only way to get these skills down is to drill them. If you need them quickly during that timed exam, you're going to have to be able to recall them like snapping your fingers. And then the only way to do that is just to hammer it over and over again until it sticks in your head. So okay, let's take a look at rule number 1 here. Now, what that's saying is the derivative of c is 0. Now you're going to see c a lot in this course. I hope you've seen it already. C means a constant. What's a constant? 7 is a constant. Y is not. Y is a variable. So basically the derivative of any plain number is 0. And that should make sense because again the derivative is the rate of change. Has 7 changed since it was invented? No, it's always 7. If something's exactly 7 miles away, it doesn't change and still remains 7 miles away. So the derivative, dy dx, x there, of 7 is 0, forever and always. So, okay, that one was pretty brain dead. Let's move on to the next. Now what this is saying is the derivative of x to the n is equal to n times x to the n minus 1. When you have an exponent variable, like say x squared, you take the exponent down, make it a coefficient, and then decrement, that is to say lower by 1, the remaining exponent. Pretty easy in practice. Let's take a look at it here. dy dx of x to the 4th is equal to 4 times x to the 3rd. Now please notice that 3 here is 4 minus 1, and the 4 is out from front. That's all it is every time when you see something that looks like that. All right, let's knock out another one here. Now what this one is saying, when you have a constant multiplying anything and you want to take a derivative of that thing, the constant is unaffected. Now remember in the first easy rule, the derivative of a constant all by its lonesome is a flat 0. But the derivative of 7x, for example, would just be 7 times the derivative of x. Let's show you a little harder one than that. dy dx of, well, let's do the above example. 7 times x to the 4th. The 7 stays there. The 4 comes down, and the x is decremented by 1. Now, of course, you would want to simplify that for your instructor and for the auto grader. 28x to the 3rd. No problem, right? Okay. Now let's see the last one here, which sort of puts it all together. The last of the 4 easy rules says that if you have one thing added or subtracted from another thing, a u and a v, and you want to take the derivative of the whole bunch, it's the same thing as the sum or difference of the derivative of the pieces. Which is to say, when you get a big long polynomial, 17x squared plus 100x to the 4th plus 19x, you just take the derivative of each piece and then put it back together. So let's try one. Y dx of, let's get an uglier expression. 7x to the 4th, which we remember from above, and we remember the derivative of this piece is 28x to the 3rd. I'll just put that up there for reference. Plus something else. How about 5x cubed? Well, turns out the derivative is just the derivative of that first piece plus the derivative of the second piece. Just as easy as you could imagine. Okay, well that is how to take the derivative of any polynomial. You'll need this information for finding out tangent lines in the next section. Stay tuned and go do your homework and join us for the next video. Thank you.